Hello students, my name is Shashank Shekhar. Let us start with the NCERT questions of some basic concepts of chemistry. So what does the first question says? We have to calculate the molar mass of the H2O. So for that we have to calculate the contribution from each atoms. So first of all we have hydrogen atoms, so two hydrogen atoms. Therefore the molar mass would be equal to molar mass will be equals to how much? Equals to how much? Say. So first we have two hydrogens and we have one oxygen. So one hydrogen will have a mass of 1 and one oxygen will have a mass of 16. So 16 plus 2, that would give us 18. Now what is being asked? It is asked the molar mass. So 18 gram per mole. Okay. Now next what is the question? What we have to find? We have to find for say we have to find for CO2. So for CO2 molar mass is equals to, so CO2 has one carbon, CO2 have one carbon and two oxygen. So how we'll do it? So one carbon, so 12 into 1 plus 16 into 2. So 12 plus 32, that would give us 44 gram per mole. Right? Next is CH4. Next is CH4. So how we will do it? CH4. So molar mass will be equals to 1 carbon, so 12 into 1 plus 4 hydrogen, that is 44 into 1, that would give us 16 gram per mole. Let us see the solution. So for H2O, 2 into atomic mass of hydrogen plus 1 into atomic mass of oxygen, that would give us 2 into 1.08084. And see, one more thing I want to mention here. So we have to calculate the molar mass and not the molecular mass. Okay. So the answer would be in grams. Answer would be in grams and not in U. So the small things are very important to notice. Okay. So you don't have to be just casual with this all thing because these things matter. Next for carbon dioxide, we have one carbon. So again here it will be molar mass. So that would give us gram, 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 gram and gram. Gram, gram and gram. So the answer would come in gram. Then what we will do for one again. So same thing has been done here. So the answer comes out to be 44. Next is CH4. So how we will do for CH4? So it would give us gram, gram, and answer will be in gram. With molar mass and not molecular mass. Calculate the mass percent of different elements present in sodium sulfate. So how, in sodium sulfate, in 1 mole of sodium sulfate, 1 mole of sodium sulfate will have, sodium is equals to, will have, what mass of sodium will be present here? So since two sodiums are present and one sodium has a mass of 1 mole sodium has a mass of 23. So 23 into 2, that would give us 46 gram. Now mass of sulfur that is present. So 32, because only one sulfur atom is present. So 32 into 1, that is 32 grams. Next is mass of oxygen. So 4 moles of oxygens are present in 1 mole of Na2SO4. So 1 mole has a mass of 16. So 16 into 4, that would give us 6 4 24, 4 1 4 to 6. That is 64. Now once we got the mass contribution of each of this, now let us calculate the percentage mass of, say first we have sodium, which has a contribution of 46 plus 32 plus 64. 46 plus 32 plus 64 into 100. So 6 to 8 4. 6 to 8 and 4 12, 1 carry, 6 4 10, 1 14 into 100. That would be for sodium. What would be the mass percentage of sulfur? It will be 32 by 142 into 100, and mass percentage of oxygen 64 by 142 into 100. So if you calculate these three, you will get the mass percentage of each of this: sodium, sulfur, and oxygen. So let us see the solution. So first of all, the molar mass of sodium is calculated in this way, which gives us 142. Now for each element, we will calculate it separately. So for sodium, it will be 46 by 142 into 100. That would give us 32.4, right? Mass percent of sulfur. So 32 by 142 into 100, that is 22.6. And mass percent of oxygen. So 64 by 142 into 6, that is 45%. Next is calculate the empirical formula of oxide of iron, which has 69.9 percentage of iron and 30.1 percentage of dioxygen. So in 100 gram of iron oxide, we have 69.9 gram of, say, iron and 30.1 gram of oxygen. Clear? Now this is the mass, so if you have to calculate the number of, say, moles, that would be 69.9 divided by 26, sorry, 56. That is the number of moles of iron, and number of moles of oxygen would be 30 by 16. So once you calculate it, you will get approximately 1 point something, and this is also 1.9. It is close to, say, 2, would say. So it would be FeO2. Okay, it would be FeO2. So 1.25 for this and 1.88 to this. So that would be 1 to 1.5. That is 2:3. So they have taken the ratio of this all. That results in 2:3. Therefore, the empirical formula is this is 20 Fe2O3. Next is calculate the amount of carbon dioxide that could be produced when 1 mole of carbon is burnt in air. So when carbon is burnt in air, that gives us carbon dioxide. Now in 1 mole of carbon reacts with 1 mole of oxygen to give 1 mole of CO2. Okay. So what is being asked? So what is the amount of carbon dioxide that can be produced? So since 1 mole of carbon dioxide produced and 1 mole of carbon dioxide has a mass of, so we have calculated this earlier, it will be 12 plus 32, that would give us 44. So 44 gram of carbon dioxide will be produced. Now next, 1 mole of carbon is burnt in 16 gram of dioxygen. So we again take the reaction. It is CO2. So what is the number of moles of O2 in 16 gram? Number of moles of O2 in 16 gram, that would be 16 by 32 or 0.5 moles. So 1 mole of this react with 0.5 mole is reacting with 0.5 mole. Now each equivalence of this would require one equivalent to this. So if 1 mole of this react with 1 mole of this, so 0.5 will react with only 0.5 of this. So therefore 0. After the reaction is completed, we will be left with 0.5 mole of carbon and 0 mole of O2. Now since only 0.45 mole of this has reacted, so that would result in 0.5 mole of CO2. And in 0.5 mole of CO2 we will have 0.5 into 44 gram. So mass of CO2 would be this much, 5 for 20, 22. That is 22 grams. After that, 2 moles of carbons are burnt in 16 gram of dioxygen. So whether we take 1 mole or whether we take 2 mole, so if we take 2 mole, then we will be left with 2.5 mole again. But the reacting species will be 0.5 only. So 22 gram will be again the answer. So if we just compare it with the solution, so that is giving us 1 mole. This is giving us 22 grams. And this is also giving us 22 grams. Okay, clear? Calculate the mass of sodium acetate. So we have to calculate the mass of sodium acetate required to make 500 ml of 0.375 molar aqueous solution. The molar mass of sodium acetate is this much. So what are the things that are being given? So we have to calculate molar solution. So molarity is given. Molarity is given as 0.375 m of sodium acetate solution. And the volume is given. Volume is given as 500 ml. So if we convert this 500 ml into liter, that would be 0.5 liter. Now we know the formula of molarity. It is number of moles divided by volume of solution. So that would give us number of moles is equals to 0.5 into 0.375. So this will be the number of moles. Now we have to calculate the mass. So mass is equals to, so we know that number of moles is given mass by molar mass. So given mass is equals to molar mass into number of moles. So number of moles we have seen, it is 0.5 into 0.375 and molar mass is 82.0245. So that would give us the mass in grams. Is this clear? So let us see the solution. So 0.375 moles of sodium acetate, that means 1000 ml. Okay. So if you are multiplying this with this, then we will get, so we are again multiplying the same thing, right? So do not get confused. If you divide 500 by 1000, that would give you 0.5 only, right? So we are doing this multiplication only, so we got this thing. Now the molar mass of sodium acetate is this, so we have multiplied all of these three to get 15.38 hydrogen, so sorry, 15.38, this is wrong, gram of sodium acetate. Calculate the concentration of nitric acid. So we have to calculate the concentration of nitric acid, that is HNO3, in moles per liter. So which has a density of this much. So we have this density, and the mass percent of nitric acid is in it is 69%. So what are the two things that are given? So first density is given. Density is how much? 1.41 gram per ml. Okay. And the mass percentage is given of what? Nitric acid. So mass percentage of nitric acid is given. So HNO3 is the nitric acid. That is given as 69%. So first of all, we need, what are the things that we need? We need the number of moles. So we have to calculate the moles per liter, right? So we need the moles and the liter, means that is the volume. Is it? Is it? Yeah. So how we will calculate? Say. So first of all, it is written that in 1 ml, we have 1.41 gram of what? Solution. Okay. So in 1 liter it will be 1.41 into 10 to the power minus 3 gram of solution. Isn't it? Huh? So in 1 liter we have this much gram of solution. Now what is it being given? That out of this gram, 69% is HNO3. Okay. So we will calculate 69% of this. So mass of HNO3 in 69% of 69% in 69% in 1 liter. Okay, that is 69% of 1.41 into 10 to the power minus 3. 1.41 into 10 to the power minus 3. Okay, so this is the mass of HNO3 in 1 liter. Okay, now what we will do, once we calculate this, so we got the mass that is present in 1 liter. Now if you want to calculate the number of moles in 1 liter, then it would be 69 by 100 into 1.41 into 10 to the power minus 3 divided by molar mass of HNO3. So molar mass HNO3 would be 1 plus 14 plus 48, 16 3 is 48 for oxygen. So 8 4 12 1 13, 1 carry 4 to 6, that is 63. Is this clear? So once you calculate this, you will get the number of moles in 1 liter. Now that is the thing we are being asked. We are being asked that what is the moles of HNO3 that is present in 1 liter, and that is our solution. No problem. So let us see the solution. So mass percent of HNO3 69%. Thus 100 gram of this much content 69 gram of HNO3. Now molar mass we have calculated. So 69 by 63. Now they have done the same thing, only they have done it in a different way. You can do it in the either way also. So they have calculated the number of moles, and now volume of 100 gram of this much will be, so they multiplied by 100, and that is our volume. And then they have calculated the concentration, means they have calculated the number of moles in 100 gram, and they have calculated the say volume in 100 gram by using the density, the number of moles, the volume is both are there, so we can do it in this either way. That would give us a concentration of 1.444. If you do it by the previous method also, which I have, if you calculate at this value also, you will get the same answer. That is 15.44 mole per liter. Next, how much copper can be obtained from 100 gram of copper sulfate? So this is the question, that how much copper can be obtained from 100 gram of copper sulfate. So how you will calculate it? So first of all, you will calculate the number of moles of CuSO4 in 100 grams. Okay. So let us calculate the molar mass of CuSO4. It is 159.5 grams. So molar mass of CuSO4 is 159.5 gram. Now next, we are given 100 gram. So number of moles of CuSO4 in 100 grams would be how much? It would be 159.5 by 100. Sorry, number of moles is given mass, that is your 100 gram by molar mass. That is 159.5. So this is the number of moles. So this is the number of moles that is present in 100 gram of CuSO4. Now, 1 mole of CuSO4 contain 1 copper, 1 mole of copper atom. So this much moles of copper, this much moles of CuSO4 will contain the same amount of copper. This will be the amount of copper also. Number of moles of copper would be also 160 by 159.5. Okay. Now, if once we got the number of moles, if we multiply it by this molar mass, that is 63.5, then it would give you the mass of copper in 100 gram of CuSO4. Is this clear? So let us see the solution. So 159.5 gram contains 63.5 gram of copper. So 100 gram will contain 63.5 by 159.5 into 100. That would give us 39.81. So you can do it in the either way. Determine the molecular formula of an oxide of iron in which the mass percent of iron and oxygen are 69.9% and 30.1% respectively. How you will do it? So let us see. So first of all, we are given that 69.9% iron is present and 30.1% oxygen is present. So we will calculate the number of moles for each of 100 gram, right? Then we will calculate the ratio, that is given Fe2O3. Now according to the empirical formula, the molar mass, the mass will be equals to 159.7 gram. Okay. Now the molar mass is already given for the molecular formula, that is 159.69 divided by 159.7. That would be 1 approx. So the molecular formula will be same as the empirical formula, that is Fe2O3. Next is calculate the atomic mass of chlorine using the following data. We have to calculate the atomic mass. The relative abundance is given. So its formula is very simple. That is the relative abundance. So we have to first convert this into fractional form. That would give us 0.7577. And this will give us 0.2423. If you multiply this by this and this by this and add both of this, if we add both of this, multiply this by this and add both of this, then it will give you the average atomic mass. So first they have converted it into this and this into this. Then they have multiplied it with the relative abundance. And finally it gives us 35.4527. That is being approximated to 35.45 U. In 3 moles of ethane, calculate the following. The number of moles of carbon atom. First is number of moles of carbon atom. So we have 3 moles of C2H6. Now 1 mole of C2H6 contain 2 moles of carbon. So 3 moles of C2H6 will contain 2 into 3 moles of carbon. That is 6 moles of carbon. A number of moles of hydrogen. So 1 mole of C2H6 contain 6 moles of hydrogen. So 3 moles of C2H6 will have 6 into 3 moles of hydrogen. That would give us 18 moles. Next, number of molecules of ethane. Number of molecules of ethane. So we know that 1 mole of anything, whether we take ethane, methane or molecule or atom or anything, will contain 6.022 into 10 to the power 23 atoms. So 3 moles of ethane will contain 3 into 6.022 into 10 to the power 23 atoms. So it's 3 to just 6, 3 to just 6, 3 6 18 into 10 to the power 23. That would give us 1.8066 into 10 to the power 24 atoms of ethane. Is this clear? Now next. So this is the solution that 1 mole of C2H6 contain 2 mole of carbon atom. Therefore, number of moles is 3 into 2, that is 6. So again, 1 mole of C2H6 contain 6 mole hydrogen atom. So 3 moles of ethane will contain 3, 6, 18. Again, 1 mole of C2H6 contain 1 mole of ethane molecule atoms. Therefore, 3 moles of C2H6 will contain 3 into 6.022 into 10 to the power 23 molecules of ethane. So this was for today's class. We will continue with rest of the questions in the next class. Thank you.